In this lesson, we'll discuss compound inequalities. For compound inequalities, we're looking at joining two inequalities, either with the word and or with the word or. First up is and. If we take a look at the inequality x greater than -1 and x less than 3, the idea with an and inequality is we need to satisfy both inequalities at the same time. We need to find x values that are greater than -1 and less than 3. So we have all the numbers between -1 and 3 being solutions. We can write this on our number line, where if we take x is greater than -1, I'll start at -1 and go up, and x is less than 3, I'll start at 3 and I'll go to the left. And notice in our number line, there's only this block of numbers between -1 and 3 that have both colors from the two inequalities. So we would say that our solution would be from -1 to 3, using parentheses to indicate that x cannot equal either of those. Considering this in two sets A and B indicated by circles, the intersection would be given by where they overlap, what they have in the middle. We say the intersection of two sets A and B is given by the symbol for intersection, which looks like an upside down U. All the x's such that x is in the set A and x is in the set B. If we're looking to find the intersection of these two sets in number 5, I have the set 1, 2, 3, 4, and another set 2, 4, and 5, and I'm looking for what do they have in common? What do both sets have? Both sets have a 2, and both sets have a 4. So the intersection would be given by the set containing just 2 and 4. In the two sets in number 6, I have 1, 3, 5, and 7 in the first set, and in the second set 2, 4, 6, 8, and 10. And I want to know what they have in common. Well, they have nothing in common. And since they have nothing in common, there is no intersection. We call this the empty set. If we work through an inequality and we get an empty set, we would say the inequality has no solution. But for our inequalities, we're not going to be looking at just whole numbers. We'll be looking at a continuum of numbers on the number line, all real numbers. So we're going to write them as intervals instead of listing them out. What is meant by the intersection of two sets? The intersection is what the two sets have in common. What elements are in both of the sets? Some examples. In number 8, we have an interesting inequality. This is actually called a three-part inequality. We call it a three-part inequality because of 1, 2, 3 parts. And also, I can break this apart. I have to break it apart very carefully in that I repeat what's in the middle. So we can write this as an and inequality, -3 less than 2x plus 1, and 2x plus 1 less than or equal to 3. I have an and inequality. I can solve it just like we solved linear inequalities in previous courses. The idea is just like solving linear equations. We want to get x by itself on one side of the equation and the numbers on the other. Same ideas with inequalities. X on one side of the inequality, numbers on the other. With these situations, I'm going to start with the setup on the right, showing you the two separate inequalities, and then see how it's related to doing a three-part inequality all at once. So let's start out with the right side. I need to get x by itself. So in the first inequality, I'm going to subtract 1 from both sides. And then again, trying to get x by itself, I'll divide by 2, and I end up with -2 is less than x. Doing the other inequality, I need to get x by itself, so I'll subtract 1. Need to get x by itself, so I divide by 2. X is less than or equal to 1, with an and between them. In this case, we can draw our number line. I'll put -2 and 1 on there, and using different colors to indicate -2 is less than x, so x is going to be to the right of -2, and I'm not going to include -2. And x is less than or equal to 1, less than or equal to means x is to the left. And looking at the overlap, what area of the number line has both colors on it? And the part of the number line that has both colors is -2 to 1, and we keep the brackets the way that they are. That's our solution. Okay, well, how does that relate to the three-part inequality? Well, notice that when we split them apart and worked them through, we subtracted by 1 first, and then we divided by 2. We did the exact same steps for both of the inequalities in our compound inequality with and. So we need to be able to do that. We need to be able to do that with our three-part inequality. The idea for a three-part inequality is whatever we're trying to get x in the middle by itself. So we're going to do the same operation to all three parts of the inequality. The left side, the middle, and the right side. So here we go. Trying to get x by itself in the middle. I'll start out by subtracting 1 from all three parts. And I have 2x in the middle. And then I divide by 2, but whatever I do to the middle, I do to the outside parts. -2 less than x less than or equal to 1, and we get exactly the same answers that we did when we split it apart. It doesn't matter which way you use it, whether you decide to split it apart and copy, and this is a key word here, copy over the entire middle expression, solve it that way, or keep it as a three-part inequality and solve it all at once. Either way is perfectly acceptable. You'll get the same answer. Just make sure that you do all the steps mathematically correctly. In looking at number 9, let's work through this one. I want to get x in the middle by itself, so let's add 2. And this one's pretty nice because x is already a single x. We don't have to divide by anything. We get x between 1 and 9. On our number line, 1, 9, I can either notice that x is between them, and I'm not including 1 or 9, so that gives me the interval from 1 to 9. Or I could take them apart and do individual graphings. 1 is less than x, so x will be to the right. And then x is less than 9, so x will be to the left. And again, I notice what gets colored by both between 1 and 9. Make use of your colors. Feel free to make your notes colorful, as long as it helps you to understand this stuff better. I do want to skip down to number 11. Try number 10 on your own. Take a look at number 11. -4 less than 5 minus 6x less than 8. I like doing the three-part inequality because it requires a little bit less work. It just requires me to pay a little bit more attention. So I'm going to try to get x by itself in the middle. First up, I'll subtract 5 from all three parts. And we get -9 less than 6x, less than -6x, less than 3. And now I want to divide, so I get x by itself in the middle. Dividing by -6 does leave me with x in the middle. 3 divided by 6 will give me -1/2, and -9 divided by -6 will give me 3/2. But when we divide by a negative number, dividing by a negative number causes us to reverse the direction of our inequalities. We need to make sure that this step happens. We reverse the inequalities, because if I take out, let's write one more step, 3/2 greater than x greater than -1/2. If I take out x and an inequality, I need to make sure that what's left over is still true. 3/2 greater than -1/2. Yes, that's still true. And if I switch it, and instead of taking out x and the right sign, I take out x and the left sign, I still have 3/2 is greater than -1/2. So that still makes it true. we always want to make sure with a three-part inequality, if we take out the middle and one of the two signs, we still maintain a true inequality with the outer parts. So we have 3/2 is greater than x is greater than -1/2. Or if I want to switch it around so that it comes from smallest to largest, then I would write -1/2 x and 3/2, but I need to make sure that my alligator, my inequality symbol, is still facing the same numbers when I switch things around. So I have a correct answer for my inequality here, but it might be a little bit easier to graph if I turn everything around. So between x and -1/2, notice that my inequality symbol is pointing towards the negative, or if I think of it as an alligator, the alligator is trying to eat the x. I want that inequality to maintain that relationship. So if I'm switching the order of the numbers, I have to switch the inequality symbol. Notice that this is very different from what we did before with dividing by the negatives. Dividing by the negatives, we're being forced to switch them to maintain the correct relationship. Here, we're not dividing by a negative or anything. We're keeping the same. We just need to make sure that we're maintaining the same relationship between all the numbers. So 3/2, the alligator's trying to eat it. The alligator still needs to try to eat it. And we can draw our graph, -1/2 to 3/2. If I'm graphing these, x is greater than -1/2, so I have greater than -1/2. X is less than 3/2, so I have x less than 3/2. Looking at their overlap, x is between -1/2 and 3/2, and I can write that interval notation, -1/2, -1/2, 3/2, all with parentheses. In our next lesson, we'll talk about the or compound inequality and how things can change. And we'll also do one or two more examples with an and, where we end up not having a three-part inequality. We have other types of inequalities that still have and in them, and also possibly some inequalities thrown in that have no solutions.